Okay, good afternoon everyone, and welcome to the grand opening of Tampere AI Hub for Intelligent Machines. My name is Heikki Huttunen and I'm chairing this event, and let me announce the first speaker, Dean Mika Grundström, the role of AI in the new Tampere University, please.
Thank you, Heikki. Happy to be here and see so many faces from the academia and industry alike, even if the Christmas is approaching very fast. Glad that we can have this opportunity to talk today about the AI and how it fits into the Tampere University's agenda in particular. So my name is Mika Grundström. I'm the Dean of Faculty of Computing and Electrical Engineering. And as with many of the openings that we have had past years, these things are bigger than such one region, one university. And that's the same situation with the AI Hub that was supposed to be there, and it's not yet. That's been established and which will be growing in our neighborhood. We start today with the intelligent machines and industrial AI, as Heikki pointed out. As from the Finnish landscape, we know that there are a few centers of excellence that are building in this region and this country, and this is our view of current situation, and highlighted now the things that where we are coming from as the Tampere University of Technology, strong in imaging, visual communication, signal processing from past not only 5, 10, but 20 years at least. And that is something that grows in our expertise in becoming one of the hubs in the AI domains. Apparently, the intelligent machines has been one of the focus areas for Tampere University of Technology, along with combining the excellence of few faculties, along with the university, has brought us into a situation that we have very strong representation and foothold and research agenda for the intelligent machines. AI Hub concept is something that will emerge. Today we are launching something that is more or less focused, let's say, more industrial, maybe more tech focused. But as we go forward, I believe that this AI Hub concept will be open. It will be networking not only with the industrial academic partners, but also with the industrial partners, along with engaging together in doing things in real. So what is most kind of a prestigious thing is that there are things and problems, areas that we solve together with the industry, for example, or society at large, which then engages the research and connects that with the society. As what comes to the new Tampere University that starts working on the January 1st, 2019, so it's roughly less than 4 weeks to go. I believe that this is one way of seeing that how the things are done in the new Tampere University. So from today's agenda being more in the left side, and then touching upon the health science, where the Moncef has a presentation today. Then we have the society part that is then touched maybe in the follow-up workshops like this one, which probably then talks about the things that are close to society. And in that area, for example, intelligent network society is one of the concepts that have been developed and has been one of the profiling areas of the current University of Tampere, for example. So I think there are many connections, many networks, many emerging opportunities that we can harness and take advantage of. And this is a great start for new journey in this area. So welcome on my behalf. I'm happy to see you here and happy to have a question if you have any. But if you don't, then Heikki has the magic wand to decide what to do. Anybody, any questions?
Okay, let's move forward. The next 3 talks will be from Laboratory of Signal Processing at TUT, presenting our expertise and existing work on the domain of artificial intelligence and intelligent machines. I seem to have slight problems with the display, but please, Joni, go ahead. Joni Kämäräinen, head of Signal Processing Laboratory.
Nice to, at least I need to see my slides, or I don't know what to talk. All right. Meanwhile, when Heikki is trying to fix it, all right, I'm telling you mostly now about the signal processing, because you cannot tell about AI in Tampere region without telling about the signal processing. I mean, up till a few years ago, the story of signal processing was almost equivalent to the story of AI research in Tampere region. I claim that the majority of all the publications in the top places on AI has been published by the researchers in our laboratory. But now it is changing. I mean, the history was signal processing, but the future will be this whole new university and all those companies in this region. I will try to explain you why. I will first tell you about some facts and figures about the signal processing. Look, we have basically 130 people at least now working there. We have 14 professors working in different disciplines of the, now we used to call it signal processing. We still love that word because it brought us so many nice things in the past. But more and more these people are doing things called machine learning and pattern recognition, computer vision, audio analysis, things like that. And those are kind of like very core business of AI research. That's why I claim that more or less this laboratory is almost equivalent to AI research. But now it is changing. When we are combined, actually there will be the new department of computing in the new university. I counted that there will be roughly 430, 450 people in this department of computing. And I would estimate that half of those people are more or less working in the fields that are very much related to the AI. In a way, it is really becoming one of the biggest, if not the biggest, kind of like academic institution to doing this research. So in that sense, everyone being in this region of Tampere and Pirkanmaa and so on, companies, Ammattikorkeakoulu, the new university, this is a very nice place to continue that research. I counted, for example, on top of the signal processing, we will have topics coming from the Tampere University like natural language processing, which means that any kind of like textual data you have, it can be processed automatically using those methods. Genomics and medical data analysis. This is something that one day branched from the signal processing, but now in a way we are coming to the same location. Genomic data, all kind of like data produced by medical institutions, hospitals and so on are analyzed by these AI methods. Economical data analysis. This is kind of like, I would say, a very kind of like strong brand in the future, which means that all kind of business data, business decisions and everything are based on AI systems. Moreover, AI hardware. I don't know any other place in Finland where we actually develop hardware to make deep learning computational things faster and so on. This is coming from the Laboratory of Pervasive Computing here in Tampere University of Technology. So actually, I could say that in next year, starting January 1st, 2019, ask me anything about any branch of AI and I will direct you to the correct person who knows everything about that topic. Now I go back to the history, a bit about the signal processing. What we do is imaging and computer vision, we do pattern recognition and machine learning, audio and signal processing. This is roughly those 3 different regions where our people are now more or less concentrated. I will show you a few examples what that means. Well, teaching profile, we are producing those AI related degrees. That means that now our income of the technical university is only 150 new students, Finnish students plus 60, at least 60 international students, but the both numbers are growing. They will be roughly next year probably 200 and 100 that we are taking in of those new students and producing engineers for the, and this is not even counting the Ammattikorkeakoulu yet. So I mean, we will be the source of those people that actually develop the AI in the future, pretty much in kind of like the second biggest or the biggest in Finland. The only one that we somehow compete is Aalto University. Ranking is roughly 200. I mean, this is all, if you think that there is some 20,000 universities in the world, that means that we are within the best 1%. I mean, if we want to make that number to 100 or 50, which we want to do, that might take 20 or 50 years, but we will do it anyway. But I mean, to go there, we really need to invest on people, and we really need to invest resources to those people that they are able to produce research that will take us to the next level. I would say that being within the 100 is something reasonable, but of course it will take some years. Now I will show you some examples. For example, the funny thing is that if you go and check the best researchers in this university, I would say that at least half in the top 10 rank are as well from our laboratory. This paper is probably the most biggest impact paper from this university. These guys, Karen and Alessandro, they are doing imaging-related AI research. Also traditional signal processing, but more and more also adapting those new technologies there. This is why kind of like this university has been attracting many companies doing imaging to Tampere. And the number of those companies is growing all the time. I counted that the demand for people that only these companies need to do that development, research and development work is probably 200 people per year. So this gives challenge, of course, to the teaching as well. But I mean, the source of teaching is always on top quality research. More about imaging and computer vision. You can find one of the nicest laboratories in Europe where you can do these immersive technologies, all kind of like telepresence technologies, display technologies, and so on. This is something that Atanas Kochev does in his laboratory here in this university. Traditional imaging and computer vision. I mean, this is one of my favorite topics, for example, detection of what is there in the image. I'll take image from this podium and I can see how many people are there. I can tell whether they are bored or smiling or snoring or whatever doing. This is what I can do based on these images. Now I, for example, know that this kind of system is used by one of those delivery robots in Tallinn that is taking actually foods to the local places. So this technology is not anymore something that we are only developing, but it is mature enough to be used by all kind of like intelligent machines and so on. Pattern recognition and machine learning, this is something, basically it is equivalent to AI. But for 15 years, AI as a term was something that no one wanted to really say. So we switched to pattern recognition and machine learning, and now AI is again trend determined, we can use it safely. This is something that Heikki and Moncef will talk more about, but this is really analysis of all kind of like data, medical data and everything. This is very kind of like a big strength of our laboratory and the university. Audio and signal processing. More and more audio is a signal that we need to understand. The last two tenure track recruitments we did for audio and language, which means because more and more your interface to the AI is not anymore that you are typing something by using your keyboard, but you want to discuss. This is what I hear more and more my kids doing with their cell phones. They are not anymore searching, and to me this is a little signal that this will definitely be how the world is in a few years. And many top companies, they are putting a lot of effort on this field, and we wanted to do the same thing in our laboratory and hire these top people, the best you can find from Finland, and now we have them in our laboratory. So everything based on the audio signal. Now we come to the new thing, something that I honestly tell that we don't know that much about. I always said that when it is a computer but no connection to the physical world, then it is fine for most of us. But now I would say that the biggest swing in science at the moment is happening in the robotics and these machines. And that's why I think that having the AI hub in this university doing intelligent machines is a very good idea. Because I mean, many people are producing all kind of like customer stuff, something that you can have in your living room, bedroom, and things like that. But those people are often overlooking the technology development which is happening in the big industry and big machines. And to me, this is still something that actually that brings the money in Finland. So I think this is a very good investment. But because we don't know anything about robotics yet, we are binding with these people who are, there is a picture, is Minna, Rule, and Reza, who are talking today as well about the robotics and how this AI stuff is related to their work. I feel that this is something where the whole Tampere region can have something very unique, combining this strong knowledge of intelligent computing with machines, robotics, and so on. There is no such a hub, if you count the number of researchers, investments, and companies in this field, in anywhere else in Finland, and even in Scandinavia, it is rather big and unique. So I really believe in this thing. Rule, will you talk about your stuff today? Okay, all right. He is a crazy guy who wants to make robots really collaborate with humans. So whatever you do, the robot is monitoring you, what you are planning to do, and so on. And then he's looking for fields or ways to communicate between the robot and the human. I think this will be first something that you will do with the little things. Probably I know that Rule, for example, likes to make bread with a robot manipulator, I remember. So he's helping, showing how to do it, and then his favorite bread, obviously, because the Finnish bread is pretty bad, so you want to bring your Dutch bread here. But I mean, soon that will move to some industrial settings. This movement, the big moving machines, this is what Reza you will talk today, Reza, about big moving machines. Okay. I will just tell that to me this is amazing, because the things that you do with the little things, I mean when the physics of the big machines come, jump in, it becomes very interesting. How you can really kind of like make those systems completely out. What I want to have is that these little robots every winter, every night, they clean all the snow automatically from this university. And when the rector comes to work, they salute the rector and show that it is completely clean there. This is what we would like to do here. The next thing is when you are really putting those intelligent systems in industry, manufacturing, and this is where Minna lands. Is Minna here somewhere? This is what she wants to do there. But her question is, of course, can we do it safely? How effective it is? And that's why we are developing these new systems where actually by using interactive displays, projectors or HoloLens glasses, those systems can communicate with each other in such a way that there will be no accidents if you take these systems to your... now we are making a system that automatically assembles an engine with the help of human and robot. I have 1 more minute. And then this robotics is really something. We first time, several months ago, we went to the top conference, Reza and me, to see what is going on in this combining AI and robotics. And I think we both got an impression that this is something that is very much going up, and this needs a communication between people for many different disciplines. And all those disciplines, even the ethics part of those robots is in this new university and in Tampere region. And this is a magnificent opportunity by my opinion. That's it. 40 years of signal processing, but now it is probably AI more and more.
Thank you, Joni. Do you have questions or comments, please?
I will throw the microphone if you have a question.
You can later ask Reza and Roland, those people.
Okay, there seems to be no questions, so let's move over to the next speaker from Laboratory of Signal Processing. Professor Moncef Gabbouj will talk about AI solutions for biomedical and industrial data, from data to decisions. Please, Moncef.
Thank you, Heikki. Good afternoon, everyone. In 20 minutes, it'd be very difficult to tell you all the details of what we are doing, but I can give you a glimpse of different things that we have been doing for the past, 10, 15 years. And I'll try to put it in a story so that you could sort of see how things are connected. A couple of years ago, we initiated a research community called Data to Decision, D2D, with people from the Laboratory of Signal Processing, also some other faculty in TUT, and a few professors from the University of Tampere, and then some collaborators from outside. And this is a little bit about the activities of the research community that I'd like to describe soon. So our approach for when we focus on industrial data and health data, biomedical type data, all this data that comes at the bottom of the slide here, they come from multi-modalities, they come at different rates, they come at different volumes. And what we do in order to reach the application domain that our industry partners would sort of require from us is we go through a hierarchical multi-layer approach. In the first layer, it is basically a signal processing layer that Joni was just describing a minute ago. That's where we put our expertise in filtering, in denoising, in representation, in feature extraction, in abstraction, taking into account the specific properties of this data. And then the second and the middle layer on there is the analysis layer, where we are putting our AI knowledge in terms of machine learning, statistical approaches, pattern recognition. All these things are embedded into this second layer, also optimization, which I will talk about in the next slide or so. And then finally, we have our interfacing application layer with the different industrial applications. So depending on what sort of applications we're working with, then we will pull the relevant data through the signal processing layer, through the learning layer, and finally to the output layer. Is the microphone working or? Okay, good. All right, so quickly, there's no work in machine learning or AI that does not reflect and make use and develop optimizations. And there are many, many paradigms in optimizations. We developed our own about 15 years ago. We call it multidimensional particle swarm optimization. It's an algorithm that is able to optimize over unknown solution space dimensionality. There is no time to explain the details here, but there is a book. If you're interested, you could find all the information about the optimization algorithm and all the applications we have done for pattern recognition and machine learning. Different functions that we encounter in machine learning and optimization, they're not very simple. They're really complicated and complex. All these gradient descent algorithms get stuck in one of those many local optima. And our optimization algorithm, as well as many other ones, are able to snap out of those local optima and give us a better results. So where did we use our optimization algorithm? Well, we used it in many places. One of them is to come up with better features than the usual what people have been working with. We call them synthesized, optimally synthesized features. The idea is to get these features to be more discriminative, to tell different classes apart. Normally they are not. Normally they are very noisy, the feature that we extract. With this algorithm, we're able to get a better representation of these features. Another thing that we used our optimization algorithm in is to be able to optimize not only the parameter of the network, but also the topology of the network. In terms of topology, this is a very simple MLP, multi-layer perceptron. The topology means basically the number of layers and the number of neurons in each layer. This optimization algorithm finds you the optimal topology of the network and the optimal network parameter, the biases, the weights, and so on and so forth. Then we embedded this optimization algorithm in, now I'm going to give you again a glimpse of the different projects that we have worked on, but of course no details due to time constraints. This is an application where we're embedding this optimization algorithm into a classifier. After we do the signal processing work here in terms of pre-analysis and feature extraction, this is for a ECG heartbeat classification, and it is a patient-specific, where we take the first 5 minutes of the patient, we use them for training. So the solution that we produce here is patient-specific. For every person, you have a different type of solution. The other thing that we were able to do with our optimization algorithm and the optimized topology of the network, we embedded the network that I just showed you a minute ago in all of these white boxes here. And we call them a network, a collective network of binary classifiers. And then we made a new classifier for media data where it is a sort of scalable algorithm, scalable classifier with respect to the number of classes and with respect to the number of features. So if new classes come up later on, we can embed new classes here and rerun our algorithm not from scratch but continue the learning process. And if new features appear, we could also embed them inside this algorithm. We were able to exploit this new classifier machine learning tool in a number of fields. This is a EEG classification problem where as new data comes in, these little guys are evolving themselves. They're changing their topology because new data comes in, annotated data, they evolve themselves and they get better and better at detecting, for instance, seizure events from non-seizure events. I'll show you some more examples in this field in the next few slides. Here's another application of CNBC where this is now a radar signal classification. And in radar signal classification, this is an example where we have a very, very large radar image of San Francisco area bay. And in order to train the algorithm, people sort of been using 20%, 50%, even 70% of the data for training. Well, guess what? This is what we use for our training. We use those patches that you see here, the little small patches. If you put them all together, they account for 0.01% of the whole data. That's all we need. And here's the result of the classifier. It's almost perfect. It is able to capture the big areas, also be able to capture the small areas like a lighthouse in the middle of the ocean here, and also this boat, and also the details on the boat. Just using a fraction, a tiny, tiny, tiny fraction of the data for training. This problem we will visit again later on. But since I'm talking about biomedical signal processing, let me stay there for a minute. Nonlinear dynamics is an extremely promising area in machine learning and AI solutions. In nonlinear dynamics, doesn't look like a nonlinear dynamic system. It's a classifier system with linear discriminative analysis and also some feed-forward artificial neural network. But the feature extraction that we are doing here relies on nonlinear dynamics. And this is an example of a nonlinear dynamic system where it is usually described by a set of differential equations. If we know the set of differential equations, then we can solve those and we can find point called equilibria, equilibrium points. And these are the points of equilibrium of this nonlinear dynamics. Could be a chaotic system or whatever. Now, in the absence of the nonlinear differential equations, if we don't know those, or if it is really difficult to solve, what we can do is we can iterate in the phase space. We can reconstruct the phase space by some measurements. And by constructing this phase space of the same signal that we don't, of the same differential equation that we don't know, this is what we get. And the conversions of these points, they point out to these points which are the equilibria. And these are the features that we extract and we put back in this guy here. We lead an ensemble classifier, and that gives us a very good results. 91.15 average sensitivity, 95 average specificity. This is the state of the art, top of the world. It is still under review in biomedical and health informatics at the moment. A lot of people talk about different types of deep networks. We have a not so very deep network of convolutional segmentation network that is trying to learn how to segment an input, trying to find the segment corresponding to this input here. And this is very simple. This is a two-layer network, 450 parameter, and it is at par with those very deep 160 level or 160 layer type network with millions of parameters. These are the results. You can compare what we have here against the ground truth, and it is visually very, very good network that was presented a couple of years ago at ICIP. And these are the metric that we use, and you can see that against all the method that we compare against here with all the data sets, we are doing really, really well. The Other projects that we worked on recently are object proposals and detecting objects from the scene. And I wanted to start with this one because this is an award-winning thesis and work that was done a couple of years ago here. In our lab is a PhD thesis of Chaler Aitekin, who was able to combine two worlds. He was able to combine quantum mechanics from physics with spectral graph theory and designing a new algorithm to be able to detect what we call the salient object in the scene. This is the input as an image described as a graph. We have the Hamiltonian here as a solution of the Schrödinger equation, and that gives us the salient object in the scene. This was and is still on top of the world. This is the best salient object detection algorithm in the world. And the thesis has received quite many recognition. So in terms of labeling, I think this was mentioned by Joni as well earlier, we combine our knowledge in signal processing and also deep learning in order to get better approximation and better localization of those objects. In the next two slides, if the video works, I'll play a couple of videos. So we are locating the specific objects in the scene, and we're also labeling them with almost very, very good accuracy in here. My best example is the next one. Again, if it works, I'll show you how it is. So this is a scene in New York where we're able to capture the main objects, including cars, buses, bicycles, people, and so on and so forth. All right. Our group is one of the pioneers group who have been developing one-dimensional CNN version. CNN, when they came out at the beginning, CNN as convolutional neural networks. When they came out at the beginning, they were meant for 2D images. We're one of the first ones who have been developing particular implementations for one-dimensional CNN. This is an example of a detection of motor faults. In particular, one particular object, or one particular part of that motor that we're interested in is the ball bearing. The ball bearing in a big motor is extremely expensive. And if it is failing, then if you don't find out where it's failing, then you have a problem. So what we did is we designed two networks for this ball bearing, one for the inner ring, one for the outer ring. And we were able to detect faults in 240 milliseconds. And I repeat, 240 milliseconds from a 2-second signal sampled at 12.8 kilohertz. This is just amazing. These are wireless sensors placed on the motor, sending us data, and we're processing the data much faster than real time. And we will tell you if your motor has a problem with the ball bearing. Another application of 1D CNN is for patient-specific ECG. We revisit the same problem again, but here we sort of present a full solution that does not require any prior feature extraction. So just out of the beat detection, when we isolate the beats, then we go on straight to that 5 minutes from that patient so that we can get a patient-specific solution. After that, we get our network, and then we're able to embed that into a portable device that sort of monitor your ECG beats. And these are the results compared to the rest of the world. I think they kind of speak for themselves. For 2 years ago, we're still the best available classifiers in the world. Now, that's a good thing for patient-specific. What about if I'm talking about you guys? You're healthy people, or assume that you're healthy. How can I detect your heart if it goes faulty one day, 1 second? Well, for normal people, for healthy people, we're able to use our signal processing expertise and design what we call synthesized bad beats. So we sort of predict if your heart goes bad, we will predict how it will behave. We will use that prediction to teach our machine learning so that we can capture and we monitor your signal, and we can capture the first time, the instant your heart starts behaving abnormally, we will let you know. This was a system that we built, and these are the results that we obtained. If you look at the confusion matrix, if you look at the precision that we got, if you look at the probability of missing the first abnormal beat is 0.174. probability of missing 3 beats in a row, 0.0053. We're capturing everything. Now, everybody is working on deep learning and deep architectures. This is one of those advanced architectures that is recently proposed in the literature. Everybody does a data-driven network parameter tuning. So they put in the data and they fine-tune the parameters. But to my knowledge so far, we're the only ones in the whole world who are doing data-driven network architecture. The architecture of the network is driven by the data. This network here is decided by the data. How many of these layers we should have is decided by the data. How many neurons we have per layer is decided by the data. Not only that, we also use nonlinear functions to make a combination of previous layers to the next layer, because linear functions are simple. They are just linear, capable of linear discrimination. Nonlinear functions are much more powerful than that. Here's another problem. A lot of people are working on reducing these CNNs, reducing their computational complexity. This is an example of a tensor-based CNN filter, and that reduces the complexity of the neural network by quite a lot. So this is employing multilinear projection, lowering the number of network parameters, and it has a faster classification due to the reduced computational cost. If you look at where we are compared to CNN in terms of number of parameters here, we are lower. So this is where we are. And in terms of classification error, we also are very low. So we're not out here. So we have faster and more compact networks. The references are here, so you could take a look at these. What if you have to design networks that take into account timestamp, time information? Temporal information is important, especially in, for instance, financial data. Economic data was mentioned by Joni earlier. This is a temporal aware neural network. It works on the bag of feature principle for time series data analysis, and we're able to capture a number of features that were really, really useful. I think because of time, I will skip some of these. I'll go to a place where we have how much time do we have? 2 minutes? 2, 3 minutes, okay. A multimodal approach. If you remember from the second slide I showed you, there are many modalities of sensor signals. We're one of the few people who are able to put these modalities together into a multi-view, multimodal approach. We use them all for learning, not disjointly, but together. Now, since the title promised something in the area of biomedical signal processing, I showed you a few glimpses of what we have been doing. I'll show you 3 challenges that we participated on recently, and we were ranked among the top teams. This is a BCI 2015 challenge. It is about the P300 speller. It's a brain-computer interface. In that brain-computer interface, we were able to extract certain features and participate in the challenge. And in that challenge, we got the 3rd place. We were happy, but not very happy. The next year's challenge was about heart sound beats. So we put the microphone to your heart. We record the heartbeats. And in this challenge with a neural network and lots of bags of features and so on, we were the 2nd place among 48 teams. When I say 48 teams, these are not from Finland. These are from the whole world, including the big names, the big universities. We are 2nd one. Well, we, of course, don't settle there, because the year after that, 2017, we won the challenge. We were the first one in the whole challenge with 75 teams around the world. And this time, the challenge was to detect this AF rhythm using handheld ECG devices. This is really, really tough, very difficult, but we were there. This is the slide that I promised to talk about today about NSF, National Science Foundation, IUCRC, CVDI. IUCRC stands for Industry University Collaborative Research Centers, and CVDI stands for Center for Visual and Decision Informatics. This is a big center with 5 universities from the US, 2 universities from Finland, and roughly 20 companies, both from Finland and the US. They get together twice a year, they do projects, The projects they are in the area of machine learning, big data analytics, AI solutions for different types of industrial data and also health informatics. And these industry data and industry representative, they're the guys who are guiding our research. I think I'm running out of time. So another book in area of signal processing that is sort of helping us get ahead in this field. And in summary, we'd say that our research community focuses on new machine learning paradigms for AI, leading to AI solutions for different types of industrial data. And this work will not be possible without the participation of our team members, for whom that I salute and thank for their participation. Thank you very much.
Any questions from the audience to Moncef?
You can also ask without the microphone, if you wish.
Not, maybe we can move forward.
So, hey, if I may. You showed so many algorithms and different ways. So, taking a company perspective, so company wants to design something. So, how to pick the right algorithm? Where to start from? You are developing all the time new ones, so that's even harder.
Yeah, extremely relevant question in this area of industrial data and management. What we do at the beginning, if you remember the first slide, we had those sensor data at the bottom. We study what sort of data is available for the particular problem. That many different data require different processing. Once we analyze the data, if the data has a dynamic, nonlinear dynamics, and we can apply our nonlinear dynamic system. If the data requires simple neural network solution, we apply simple neural network solution. We don't try to kill a small bug with a big hammer. So we try to size the type of methodology to the specific problem and the type of problem we have. And that requires a lot of trial and error and discussion with our industrial partners.
And to top up that, recruit people we educate. Doctors and engineers, they know.
Thank you.
Okay, thank you. So let's move forward with the program. So next one is my turn, and maybe after the very good introduction by our professors Joni and Moncef, we could describe the essence of this event. So we are now launching a new AI research center here in Tampere, and I would like to say a few words about that. Maybe before that, maybe I could introduce myself briefly and tell you a small story which gave maybe the insight to founding this new event and new organization, AI Hub here in Tampere. So apart from my daily job as an associate professor here at the university, I'm also a partner in a small company here in Tampere called Visu. And what we do there is automatic license plate recognition systems for access control. That's the essence of our work. We do also other kinds of OCR stuff, optical character recognition stuff, but the essence is in license plate recognition. So when you drive out of Hampinparkki, for instance, your license plate will be read by our camera-based recognition system, and it tries to make your life easier that way. And in that role, I've been working together with TUT in a different manner. So I've been sort of a mystery shopper. We sometimes have problems that we can't solve ourselves. Usually they are related to mechanical engineering and things that we are not good at. And then I told my colleagues at the company that maybe we could try the company services here at the university. Pasi Vakaslahti, the head of the organization, very kindly answered to the company, and it was a nice mystery shopper experience for myself. I saw how the companies see and perceive the university services for companies. The services are very good. They offer all kinds of discussion events and all kinds of expert services that you could take advantage of in your company. However, I was kind of missing something in that role, so I wish that there would be more resources to help the companies out in their difficult problems. And This is one of the key ideas of the AI Hub Tampere. We want to make the life of companies easier, and we want to make the adoption of artificial intelligence easier for the companies in their daily lives. So today we are launching the AI Hub Tampere, which is a Tampere-based artificial intelligence research center, and our intent is to help companies take advantage of the modern artificial intelligence. We organize workshops, help desk sessions, all kinds of experimental piloting. With the kind help from our supporting organizations, with the funding that we have, we are able to also run short pilots. This was one of the things that I was wishing in my earlier life within the company, to be able to get not a full proof of concept, but maybe at least some kind of pre-study what can be done in our problem using the modern artificial intelligence tools. And our key principle is to make artificial intelligence easy to reach for everybody. People talk about democratization of artificial intelligence. So I'm within this movement and I want to support it with the best I can. So therefore I want to make it more accessible, affordable for everyone, and to this aim all of our services, help desk sessions, workshops and so on, are free of charge. They are funded by public money, so should be accessible for everybody. And one of the things that I want to stress is that we are a neutral, publicly funded center. By neutrality I mean that quite often there might be some consultancy services that are helping you with your AI related questions, but they might not be that neutral. They want to give a positive answer to your initial questions. Yes, we can do it, and you can do it with us. So instead of that, we are not seeking for money, but we are neutral in our services, and we'll give you an honest answer regarding your specific questions. So some of the goals that we want to tackle in our program is that we want to train engineers to implement AI, but we also want to train managers to outsource AI. This is one of the things that might be difficult in the high hype of artificial intelligence today. It is difficult to buy AI. You don't know what's the price. You have some problem, and then there's a company offering you a solution for that. But it's difficult if you haven't done it before. You have no idea how much you should pay. They are asking for somebody, but for some amount of money, but it's difficult to say if that's too much or too little. So we are training managers, we are training engineers to implement and outsource AI in the best possible manner. And some of the other things are that we are, of course, everybody is saying that they want companies to discover the potential of AI. But maybe our peculiarity as a neutral organization is that we also help companies to understand the limits of AI. It's not a problem for us in the help desk session to say that, unfortunately, we think that AI is not the solution to your problem. As well as we might say that, yes, AI will be the solution to your problem, and here are the steps how you can solve it. And one of the key things is to try to create an ecosystem. Last week I was in the Tampere imaging ecosystem organized by Business Tampere. There was a pikkujoulu kind of event last week, and I was really impressed by the amount of companies that they have been able to attract. There will be a talk by Business Tampere in a moment, but I really admire the energy that they have had in their ecosystem building activity, and this is something that I would like to reach also within the domain of AI for intelligent machines. There were, I think, the sauna was equipped for 50 people or so, and I think there were 95 of us, and all from companies, all very active and trying to find collaborators in their respective domains in the Tampere imaging ecosystem. So we want to reach same level of aspiration in our work. And also we have some research backing up all of our services and want to contribute to research as well. Here are some of the components of the center. So there will be a separate working group working on building the network, marketing us, training, running the help desk, and also looking into theoretical aspects of artificial intelligence. This is like the essence, the most essential working group within the AI Hub. Here we are this is the center. It could be formulated just that this is the center of everything. But then we have also research groups that are collaborating with us, which are also funded by the AI Hub funding instrument, so that There are people looking at the tools, how do you do the hardware, how do you do the software, helping in your AI deployment, and how do you look at the system level concepts, not only individual, let's say, neural network, but the system level all the way from image acquisition or data acquisition to pre-processing to prediction to post-processing and to the decisions as well. Then there is the strong robotics group involved in this. There will be a talk, the last talk of today will be by Reza Ghabcheloo, who is the key player in our robotics group. And as Joni said, this is the place where artificial intelligence is not yet abundant, but in 10 years it will be. So all the big players nowadays, they are working in the cloud and they are digital services like Google and Facebook. But in the future, this will be more and more important, and we want to be in the front line of that. And how to use the AI for intelligent machine is the key question. And not to forget the human aspect, the human is collaborating with the robots, as we saw already in the previous talks. So one of the important, probably most important thing about artificial intelligence and robotics is how it interacts with humans. It should not be dangerous, it should be perceived as a companion instead of an enemy. And to this aim, we also have a working group which is looking into the human aspects of artificial intelligence and robotics. Now, the structure of AI Hub is such that we are starting our operation now, and in the current stage we have these organizations that are kindly funding us. Not all decisions are done yet, but we have a strong belief that we will get all of the funding. And then we are also in collaboration with other similar hubs. So for example, in Pori, Satakunta region, there is a RoboCoast similar program. Then University of Eastern Finland is processing and starting a similar kind of program. Then TUT has very strong competence center, the SMAC, which is right across the corridor. And we are in collaboration with them, and they are sort of our model how to make things run as well as they have done so far. Then there are also some other very important partners for us, including DIMEC, who is a key player in this ecosystem. University of Tampere, maybe I should not have it separately anymore because next month I will be here as well. And maybe as a third one, Business Finland has been the initiator of the whole idea of artificial intelligence hubs around Finland. We have separate talks of some of these stakeholders in a moment. To give some concrete understanding of what we plan to do, what is the thing that AI Hub is working on. Here are some forthcoming events this month. So today we have this AI Hub opening, but we are starting our operation immediately. So next Thursday we will have a AI hackathon for one of our important key partners, Huawei, which is located 2 floors up, their local Tampere office. And for them we are organizing an AI hackathon intended for our students. So we tell our students, yes, we organize this for Huawei, but we are sort of the organizers and the bridge in between. It might be that it's easier for the student to come to an event which is organized by a teacher of the students instead of some company who is maybe less familiar to them. So I also might understand better what they can do and what they can't do. So it might feel a safer choice to come to an event that is organized by the AI Hub, the people that they already know. And the participation seems to be quite good. We are looking into something like 60 students coming in here, and I think we are around 40 people registered so far. And then on the 17th, we were able to attract IBM University Tour to give a seminar similar to this one. They will be talking about their Watson services and what kind of things they are doing within artificial intelligence in their perspective. Then Huawei AI Hackathon will have a second day as well. And on the 10th, we will start the actual AI Hub workshop activity. Our first AI Hub workshop will be on the 10th of January, and it's sort of a pilot workshop which will give us understanding of what are the needs and what are the challenges of companies in their AI activities. And to give even more concrete understanding, the agenda for the 10th of January event is looking like this. So these are the kinds of workshops that we will be organizing. So first bit of lectures, but I want to have things as concrete as possible. So there will be a hands-on session where the engineers themselves set up their laptops and even write code, Python code, to implement certain machine learning structures and see how good they are. And in this section, I also want to try to put the engineers together to build the ecosystem. So I will take an engineer from, let's say, Glaston and one engineer from Epic and another one from Huawei and put them into a group, and they will be working together. They have no conflict of interest because they are not direct competitors of each other, but more they are forced to talk to each other, and this is probably the best way of making grassroots networking possible. And then some lectures, some hands-on sessions, and as you can see, there are many hands-on sessions, and we are doing real things there. And what I want to do with this is this nice tweet from a moment ago. So if you have been wondering what's the definition of AI and how it differs from machine learning, I think this is a nice way to put it. So if it's written in Python, then it's probably machine learning. If it's written in PowerPoint, then it's probably AI. So we are really doing things in Python, so it involves also the machine learning, the hard things, the hard core of artificial intelligence is involved. And my final slide is just showing the people who are involved at this time in this AI Hub. This AI Hub is not intended to be a short project or just a test project, but instead we want to reach longer. So we want to make this, and we will make this a part of TUT and Tampere University daily routines. And in the beginning, now these people have committed to work together with AI Hub Tampere. So if you are interested, if you got interested and want to know more, I invite you to look into our Twitter account, which hopefully is updating as we speak, right? You are writing all the time. Yes. And also our website, tampere.ai, should be easy to remember. So I recommend you take a look at that and see what are the upcoming events, and we'll update both these channels as we can. So thank you for listening, and any questions? If you have any questions, I'll be happy to answer. Thank you. I see a question there, sir.
Can you say a couple words about the confidentiality, IPR issues, and dissemination of the results? I see there might be some problems.
Yeah, the question was about legal things such as confidentiality, IPR, and stuff. And yes, this is one of the concerns that we've been looking into. And one, apart from these that you mentioned, there is also the concern that are we competing somehow with local companies? And this is not something that we want to do. So we are not competing with companies that offer their AI services. Instead, we are sort of collaborating with them. So when we have a help desk session where we discover a thing that we think that might be useful for the company, and then maybe extended a bit further with some technicalities, then we are more than willing to pass it over to a company so that they can take over it. So we are not looking into IPR, and we are not taking any of the IPRs. The legal things will be taken care of by our legal counseling, but the companies will own the IPRs all the time, and everything is confidential. Everything is following the model that is already running in for example, the Pulma-Perjantai events, and there is a good model that we are following. All the IPRs will be owned by their respective holders, and all the discussions will be private.
And I remember several times that several companies have contacted us for help, and then we found that actually by combining these companies they can help each other and they can do business together. So in that way it is also a hub. that we are not keeping it for ourselves, but for the benefit of everyone. This is how I see it happen.
Yes. Okay, if there are no further questions, let's move to the second part of this opening ceremony. So these have been scientific talks and talks by the university people, but now I would like to give the floor to some of our partners who are also funding partners in this AI Hub. And first there will be Manu Setälä from Business Finland, then Antti Siren from FIMA, and then Niina Siipola from Business Tampere. So, Manu, please.
Okay, hi everybody. Very nice to be here, and actually have to start with two things I'm very proud of. First thing is that Business Finland is used to think that we give the money. For AI hubs, we haven't given any money. So I'm proud that we have found something what we are not used to have. Of course, you wait to have money, but maybe it comes later, but not now, not in the situation. And the second thing I'm very proud of it is that the first AI hub is at Tampere. We are planning to have them around the world, around the Finland, not around the world actually, but around the Finland, and the first is in Tampere, and 2/3 of my life I have been live in Tampere region, and I have been studied in the Technological University of Tampere, so I'm very pleased to be here now. Okay, so as mentioned in the last slides, what's the difference between AI and machine learning? I have PowerPoints and I'm discussing about AI. Okay, and we think that the AI is it can be used as is. Only AI with the data and stuff like that. But in our view of thinking is that if you have this business model what you use when you use the AI, you can do something very nasty. So every examples you have here, it would be very nice to see that if you know that this company can use it for in a good way that generates new business for Finnish economy, it would be very nice to see this. And if you think about the companies, there are many companies and you can use the data between companies and use, for example, AI to refine the data better and better. Then you have a kind of a platform economy. And this is what we have in our AI business program, is this AI and platforms. So companies working together in a plan that they make the best service for other persons, for things like that, it would change the world. AI is one needed part there. As I mentioned, we have plans that there will be hopefully a couple of AI hubs, and these 6 are now something what are more planned. And come from West, Pori, Turku, Tampere, these are the leading 3 ones. And if I know correctly, Tampere was the first to announce that there is this AI business hub. And all of the hubs should have some kind of own agenda. And in Tampere, it's this intelligence machines and AI. And it's very good because Tampere is very strong with the intelligence machines. And then this AI with the existing business, they can make it grow much faster and make them very competitive. And it's something what is good. And of course, we would like that these hubs work together. So in Finland, there is not very good to have many persons doing the same. If we can share the knowledge, we are much more stronger. I think every one of you have heard about this AI business and the values of money or the amounts of money, how much is used for AI. For example, only Alibaba tells that they will use 15 US billion for this AI. So in Finland we cannot we cannot use the same money for that. Okay, so we hope that these AI hubs can create benefits for companies, this networking and partners. Of course, we can then support the companies for funding and sharing the knowledge, and hopefully we can also help for market access support. It's one thing what is in Business Finland that wasn't in Tekes when it was Tekes. There wasn't this market opportunities, market access, but now we have it. We have many places outside Finland where is our employees, and we can support this kind of international networking with that. And as I mentioned, many things, or many of you are willing to see that we are still funding for a funding agency. It's part of our work in future as well. We are mostly targeted for startups, SMEs, and mid-caps. All of these are kind of our main focus: startup, SME, and mid-cap. Then large companies should have the network, and of course the research institutes with the network, because every one of us, we are willing to see that, for example, the nice ideas Moncef just shows to us will be kind of productized, and they will make this business opportunity for companies. In our program we have 200 million budgeted, and it is this 5 years now, so 20 million a year for our funding and 20 million from other sources for companies and so on. And we have this 60 million, this capital loans, and actually first 30 million has already been given for the companies. So this Finnish word of kasvumoottori has started already, and 30 million of it has already been given, and we are willing, or we are hoping to have more money in coming years, but we know that we have 30 million next year as well. So for example, think about the situation that in AI Hub Tampere there are companies that are willing to see that they will make new business in the world about 1 billion euros in future, and they need to have a kind of company or operation that can support every single companies in the network. We can fund the company, for example, 5 million euros with the capital loan. It's very nice money. It's actually brilliant idea to have it. And the way how it is given is also very brilliant, because it's in a way that it's not governmental money, it's washed governmental money, because it's used this hankintamenettely. I don't know the correct word in English, but anyway.
Procurement process.
Okay, thank you very much. And so there will be a competition for that in next year, starting about end of February or something like that. Please stay tuned of that. And of course, this typical slides about the funding for companies, if you have seen ever one Business Finland presentation, you have seen this. So R&D grant 50%, or mid-caps for 40% for company research, and loans for productization, and this small tempo grant, actually 75%, I have mistaken my slides, and so on. But this is what we have done for years. There are some examples of that, but I try not to use my time too much, so you will have the slides so you can take a look. There are contact persons. I'm one of those. Me and Aki Ylönen are located at Tampere region, so you have quite good situation here. Thank you very much.
Do we have questions from the audience? It seems everything is clear, so let's move forward with our agenda. Thank you. Our next speaker is Secretary General Antti Siren from FIMA, Forum for Intelligent Machines, and he's talking about the need of AI in intelligent machines. Please.
Okay. Thank you, and thanks to be here also from my behalf, and I'm really looking forward for the future cooperation with the new AI Hub in the coming years. So my title is Need for AI in Intelligent Machines. So I'm a simple engineering and working with hopefully and fortunately not simple but very practical engineering of the company. So I try to be very practical in these presentations and showing some examples of the needs where AI can be used in the modern machines. And maybe Reza in the later presentation will then give answers for that because he has almost the same title. But okay. So as we probably know, there are already intelligent machines or especially work machines where I'm doing my work. And we can even say that they are field robotics and doing work autonomously or having autonomic sections or functions or having very high-end, very sophisticated communication systems and control systems. And some of the pictures may be even quite old, and that's only to show that it is not a new thing that the machines have been built intelligent and have smart features. I worked very many years ago in a company that called Tamrock, and then nowadays it is very other name, but even then we were building autonomously moving surface drilling machines there, or having a prototype of that. So it shows the time length. It was something than 1990s, so it shows the time frame of this development. And well, if we are asking, is there a need for AI in these machines which are already so smart? So the answer is of course. Of course there are need for development, and this is showing how and where it can be used. It's not only thinking the autonomous systems or very high and clever machines. Actually, it's needed in all kind of operations. It's need for operator assistance systems, and next step, if we think about that in very simple way, the development, so different remote operations, it can be used, as well as autonomic sequences. And maybe the autonomy systems, that is the high end, and maybe I would say so that all the other levels will become first and more in the time schedule before the autonomy. So the level and the role of AI and other intelligence will grow when we are coming to up, but it is existing in all the levels. I collected some practical examples about the issues, about the needs where AI can be used in maybe the next steps in this field robotics or intelligent machines, intelligent work machines. One is the abstract work task definition. It means that I'm not saying that on giving very exact commands or targets to machine for movement to movement. We can say that go to pick up this load from there, or dig a 100 meter what is that, oya here, and so on. So we can give the tasks for the machines in very high level, and the machines can perform their operations individually. Decision making, and especially in some exceptional situation, that is one thing that need to be helped still today. We can program the machines very well in the normal operations, doing its work, but what happens if something exceptional happens? So that can be one application. And then machines are not so good to learn still today. It's learning new skills or learning from their own behavior, own experience. So that is one field. The one very interesting, very big deal is the utilizing the sensor and control data which is inside the machine all the time. It's a huge number. That is called another common term, big data. So that is one very important ways to use AI. Maybe even, and it's also used already today and maybe in the near future. Then some predictive actions. The machines are not very good to anticipate what is coming or making the prediction. So that is one area which will come in the development soon. And one thing is to imitate human behavior. And as summarize of this all, very limited, but one idea is that we are trying to make humans, machines more like humankind, or humankind thinking. Because humans, that is only reference actually what we have for intelligence, operations and autonomy. So that is one target in a way. But the other thing that what we human don't have is this huge capacity of computing, and that we can also use and utilize in the modern coming intelligent machines. So I think there were some ideas where AI can be used in these machines, and I think also in cooperation we will practice, hopefully very hands-on in these situations. Here are again a little more pictures. They might show some specific areas, but in general, FIMA is working in common interests and common problems, and in spite of there are some specific, so all of them have very common and needs which can be utilized in many other areas also. So, this is some examples what is now under discussions, what the machines should be able to do next time, what is not yet possible today. For example, picking up loads which are not so even, or piling things, piling the objects on the top of each other, and go to the target autonomously, which are in environments which are unpredictable, and also how to know which kinds of terrain or ground is ahead or under your machine. And one thing more, when comparing the autonomy and what are the specific challenges of the work machine autonomy, is if you think about the autonomic cars, we have 5 levels today, and they are building the step by step in these levels. But comparing to the work machines, there are even more levels or dimensions in there. The missions are very complexity many times. It's well, driving is difficult, of course, especially in hard and circumstances, but works are very, very complexity, and also the environment is normally very, very harsh, very complexity. So there's two dimensions, and plus the other is this independence. And this table shows the area which we are working in, and what kind of challenges and possibilities are when we are moving into the more autonomous, more intelligent machines. So it's not only step by step, but there's a huge number of areas that are under research and development. Okay, that's very short summary of the situation and needs of what we have for intelligent machines, and yes, that's. Thank you.
Thank you. Do we have some questions from the audience? Maybe I could mention in one of your examples was recognition of what kind of terrain there is under the working machine. Is it asphalt or sand or gravel or grass or what it is? So we are coincidentally at the moment we are collecting in the AI. We are collecting data for this kind of experiment where in the workshops the engineers would try to build a classifier that is able to recognize what kind of terrain there is under the machine from the vibration sensors like accelerometers and such.
Yeah, that's good. And also FIMA is very open for all ideas and proposals to solve these challenges. So let's be in touch. Thank you.
Okay, thank you. The next speaker will be Niina Siipola from Business Tampere. And there we have the slides, please.
Thank you, Heikki. Hi all, my name is Niina Siipola and I'm working for Smart Tampere program. It was last June actually when we started discussions with Heikki about AI Hub, and it was very easy decision for us that we want to be partner in AI Hub. And I will shortly tell you what is the Smart Tampere program, then I will tell you about our targets and then why the decision was easy, and then I have one concrete example what we have been doing. So the Smart Tampere program is the development program of the city of the Tampere. It started 2017 and it's headed by Teppo Rantanen. It includes 3 different sub-programs. First one is the Sustainable Tampere. It's targeting carbon neutral Tampere 2030 and headed by Kari Kankaala. Second one is the digitalization program headed by Jarkko Oksala, and it's targeting that all Tampere services are digitalized until 2025. And then we have this ecosystem program, and it's headed by Seppo Haataja, and I will tell you a little bit later what is our purpose. We are doing Smart Tampere work in the themes through the themes, and we have 8 different themes. Renewable industry, smart mobility, education and research, smart buildings and infra, smart governance, AI and analytics, and connectivity and the safety and the security. And then the purpose. So the purpose of this ecosystem program is to help local companies in their renewal process, find new business opportunities to companies, promote Tampere as an attractive area of the expertise, build networks and ecosystems, and do matchmaking between the companies. And of course, offer city environment as a platform for business development. Then about this AI and analytics theme targets. So we have 3 key targets. Produce awareness of the benefits of the data collection, analytics and AI, and then support City of the Tampere to utilize AI and analytics in planning, decision making, and optimizing the operative efficiency. And then third one is to strengthen Tampere as an attractive AI know-how center. And then we have motto that all trainings and all other activities or the actions will be planned based on the company's needs and will be produced in the cooperation with the professionals. So now I think that you have a good understanding why we want to be partner in the AI Hub. And I think that Heikki nicely told already that what are the benefits of the AI Hub, so I'm not repeating those, but I want to highlight that AI Hub is also concrete asset what can be used for this invest in work when promoting Tampere AI and analytics know-how. So like Heikki mentioned that there is this imaging ecosystem, and when there has been done a lot of promoting work for the imaging know-how, we have been getting a lot of new companies in this area, and it's also our target in this AI area. And then about examples, so probably you have all seen that there is tram coming to Tampere, and we have been joining the development work together with public transport, Skoda Transtech, who is the supplier for the tram, and then Tampere Raitiotie. And we were looking for the solutions to get data how many people are in the car between the two stops. So currently public transport is getting data only when the people are going in. And because city always want that the solutions are also the cost effective, we decided that we are looking for the imaging solutions because there are cameras inside the car and then also outside the car that we are utilizing those same cameras. And we opened this pitching competition in last spring, and there were selected two companies to create proof of concept for this solution, and Symbio was one company, and this team is located in Tampere. And they were using this object recognition in this case and doing analysis based on data that how many people are in the tram. And then at the same time we were using one camera for the bus stop, so we were able to analyze that how many people are on the bus stop. And actually we were able to analyze also that which directions people are going from the bus stop. Even this was done for the tram purposes. We noticed quite soon that this data can be used also for traffic light optimization process, and also the maintenance purposes. And now we are studying also the other traffic cameras that could we use the same solutions to, for example, to optimize the traffic lights system. And company, this was very easy way to do piloting in the real environment before they are doing the product or the decision that are they productizing solution or not. So we have got a lot of good feedback from them, and now we were 3 weeks ago in the Barcelona Smart City Expo, and we had 10 companies from Tampere area with us, and Symbio was one of those, and they were testing this solution with the other cities, and actually they were receiving a lot of good feedback, and it seems that this same challenge is also in other cities. So I think that this is good example how we can use imaging also in city challenges. Okay, that was my part. If you have any questions, let me know. And I'm also staying in the networking part here.
Thank you, Niina. Do we have any questions this time? If not, let's move over to the last talk, which is once again slightly more scientific at the end, but I'm sure it will be very interesting for this audience. Reza Ghabcheloo will talk about the intelligent machines side. So far it has been maybe a bit too algorithmic, so now we go to the real machines. Please, Reza.
Thanks, Heikki. Well, the last presentation it's been a bit long. Although Heikki has reserved half an hour for me, I won't use it, so you'll get your coffee soon. As the title says, I've been working on intelligent machines, mostly big machines, as Antti Siren was talking about. As an associate professor for a few years, I joined TUT about 10 years ago, mostly working for robots, machines like that. Of course, they don't jump like that, but when I moved to Tampere, working at TUT, it was when the time was that Tampere University of Technology got the Center of Excellence on Intelligent Machines, what we call GIM. It was about 2007, 2008. There was a lot of development already on the machines. Machines were already fully controlled, what we call controlled by wire. Basically, it's electromechanical. You could control all the valves and motors and pumps and diesel engine and all those. So there have been a lot of developments already at TUT when I joined. So I've been building these, what I've been doing on top of a lot of activities at TUT. So we start doing first time we drove with one of these machines in autonomous form. It was about 2009, and after that everything continued, going from autonomous navigation to more sophisticated pallet picking, visual control, and recently more earth-moving activities. And last few years, we have been adding more and more intelligence and learning techniques and data-driven approaches to these things that we have been doing with these big machines. So as I mentioned, I don't know if I can use my mouse or maybe these. So we have been doing a lot related to controlling the hydraulics, the low-level controllers, high-level controllers from inertial sensors, the GNSS, LIDAR sensors, all sorts of other cameras, to what we call the AI, from perception, planning, and action. So in the lab, that recently is, for last 1 year has been called the Laboratory of Automation Hydraulics Engineering. We know a lot about what goes under the hood, and also we know a lot about what goes on the roof. So I want to show you through these slides that what we know mostly about what goes on the roof. I won't talk about much about the details in the low-level controllers. So one very important thing is that the intelligent machines need to interact. Well, the first part of the interaction comes from the fact that they need to be aware of the situation. They need to have interaction and the knowledge or the situation with respect to the robot, with respect to the world, robot with respect to human around the robot, and also human with respect to the robot. That's something usually is forgotten. So we know that, okay, robot needs to know where it is and where it needs to go. But what is usually forgotten is that, well, actually the human, especially if the robot is starting being used in the environment, that there are other humans and human-driven machines. So the important thing is that to be feeling safe around the robot, this robot need to somehow be predictable. So humans are around the robot and they know what's going to happen. If it's not predictable, then you won't feel safe around the robot. So this robot needs to be safe and make autonomous decisions. Important thing also about in a couple of needs that Antti mentioned is about how you communicate your intentions and communication, how you can actually easily, instead of programming, easily communicate to the robot as an operator that what you actually want the robot to do. Otherwise, all these things, well, every what we call autonomous machine is not really autonomous. It has some boundary, it needs some input, and that input comes from human. or a higher level system anyway, but it has to be, this interface needs to be happening. And also robot needs to communicate or interact with the digital models. As I said, this information or communication comes from either human or it comes from high level systems that are planned a priori, especially in Finland. The BIM model for constructions, in this case, it's quite advanced. It's one of the most advanced in the world, and we are hoping to interact more in this direction as well. We haven't had much, but this has been through the company collaboration. It hasn't been so you can see here the robot. This is still a bit old version where we had these leaders. We didn't have at the time the 3D leaders, so we had to build our own. It can map the world. It makes an understanding of the drivable areas, makes a plan, and does the replanning. So this is what we, as I said, about autonomous navigation. So it's about the thinking, seeing, and acting. In this video, it's just more advanced techniques, more sensors, more reliable. Okay, well, the robot can't move like that. This is just the video quality. This is autonomous earth moving. The technique used here is mostly what we call heuristic. So the engineers have sit there, look at the signals and how you can actually model, how you set up a state machine, look at the pressures, angles, speeds, and plan and kind of design a controller for the robot. So you actually, we have postdocs and researchers sitting hours and hours planning and writing controllers. And the problem with that is that they don't work all the time. And every time the earth changes, it's a bit more freezing, or it's cold, or it's warm, it's a bit moist, it doesn't work anymore. We use the same techniques, same controller to do snow cleaning, it didn't work. So that's a good... So what's the solution? Let's see if we can actually learn it from demonstration. So what we did is that, well, we actually tried to collect data by actual demonstration. So one of the operators, well, the skills he has is just a postdoc. He's not actually a professional driver, but we are hoping to get actual data from actual operators and machines. From pressure signals from the hardware transmission to the boom angles and the bucket angles, we fitted it and learned some simple few-layer neural networks to generate control signals on the gas, the bucket, and the boom. And well, here is the experiment we did. We have done a lot of different experiments, a different kind of architecture of the neural network, how many data, what you need to do. I can see here, again, Eric can't drive like that. So we collect data, we learn the model based on only 20 data sets. And of course, as you can see, it's quite expensive to collect data, so we want to learn it with few number of data samples. And this is actual autonomous operation. To my surprise, it worked. I couldn't believe it will work, but it did. To some extent, of course, but it's you will see. There are quite many tests, many of them successful, and of course, some also not very successful. What is that? Because, well, you train a neural network, it works in a feedback form, it gets the data and acts on it. They're always in the feedback loop. You get to the state space in the point in the state space that you don't have data. You haven't trained, so you don't really know what actually the output is. You can't really guarantee any stability. So we went on researching on stable dynamic systems. Well, these are examples of Gaussian mix models and the Gaussian regress processes. As you can see, they generate around where you have demonstrations where they are reproducing okay relatively, but the area that you don't have, you can't have really guarantee that if you start somewhere here, the robot actually moves. What you saw will happen. So we have been developing algorithms that given a demonstration, these are the red lines, you can reproduce okay, and also you can guarantee stability even if you move away from what you have been represented or you are somewhere different than you have demonstrated, you still generate some stable motions. Andre's master thesis is already available. If it's not, it will be in few weeks available in the EPUB. So this is what we have been doing related to learning from demonstration. Still some notes on the data-driven control. This is we have theoretical approaches, solutions, but we don't have yet any actual implementation. We know how to solve these control problems. Given a set of cost functions, that is standard for a control problem. You have a cost function. Let's say you want to reduce your distance to some place. And then you have a model of your robot that's actually generated, learned from a neural network. So it's a multi-layer perceptron or is a recurrent neural network. We know how to solve this efficiently. Well, more efficient than a state of the art. So that's what we are actually now generating some data, learning this model, and trying to generate a controller basically. In the other method, you actually learn the controller that we learn the controller that maps the states to actions. That was that's called the behavior cloning in the class of the learning approaches. Here, we don't learn the mapping bit from the states to actions. Instead, we learn the model of the system, and then we use a standard optimal control method to generate the controllers. So these are the main differences between these two. The rest of my talk will be about more classical control approaches. We have some novel trajectory generation methods for generating motions for robots, mobile robots or manipulators in general, but examples are mostly manipulators because they are more complex in terms of dynamics and kinematics. The results were published in IROS, combining methods of alternating projections, augmented Lagrangians for task constraint trajectory optimization. If you are not from robotics, it doesn't tell much. Even if you are from robotics, it doesn't tell much. Quite complex optimization algorithm to do optimization. Basically, you generate motion for your robot. The way you saw it, the robot goes and picks and does some action. So you want to generate motion for your robot. That's the thing. We have solved some well-known problem that has been around for robotics. Basically, what we call the cyclic motions. If you solve it for redundant manipulators, if you goes and comes back, it may come back in a different location with the traditional methods. This solves the problem. So we don't have a cyclic issues. You can solve the closed chain kinematics if you want to have two-hand manipulation, for example. This is called the closed chain. You want to have so this is also a hard problem in robotics. We have compared it to the existing solutions and validated for different applications from, let's say, obstacle avoidance, two-hand manipulation, inverse kinematics, also standard robotics problems. And in terms of speed, we are hoping, actually this is a single core implementation. But actual algorithm that we have developed is fully distributed and parallelized. So we are now trying to implement it in parallel. So we will speed up much in terms of we are hoping to have it in real time, so we can have a reactive planning, so it can be used for human-robot interaction and the model predictive control of action. Because when a robot is near the human prediction is difficult. So your prediction horizon is very short. So you need to replan all the time. When the robot is moving, a human is moving next to the robot, you need to replan and do these things. So you need to have a very fast replanner and controller. We have already solutions for reactive obstacle avoidance, which is either the human or anything else. We also have a full solution for time optimality, because most of the solutions now, they first solve the path and then they optimize the speed. So the time and speed are separately planned, so we solve all together, so we can have actual optimal problems. Okay, and now for those guys who have been working for computer vision, I took this graph from this reference. IJRR, one of the most high-ranked, prestigious robotics journals, recent limits and potentials of deep learning for robotics. So computer vision is about converting images to the information, and at the end of the loop there is a human that makes decision. Robot vision, on the other hand, you have images, and at the end of the day you want to make action. And that makes it quite complex. There are quite many challenges there. I will focus on only few of them. When we do learning, uncertainty estimate is very important, because for the robot to make a safe decision, it needs to know that, okay, this position of this object that is detected to be here, how accurate it is. We also need to identify unknown objects, because when you leave the robot in an open field, there are always potential to encountering new objects that have been classified. So it shouldn't tell if he doesn't never know Heikki, if it just says is Reza by mistake, it shouldn't happen. So it has to be a way of, you also need to be able to do incremental learning, because as the time goes, you will have more and more data coming. Well, few more here, maybe temporal and spatial. Robots are active agent, meaning that they can actually operate. It's not that you have a camera fixed there and then the data comes in. You can actually control your camera if you need it. So usually, for example, a lot of research has been in robotics in such a way that, okay, your vision, for some reason, because the features are not good enough in this region, you need to take a different route to make sure that you collect good data for your navigation. So how you solve that problem? Well, some of the things that we have been addressing related to this vision is that, well, the data you get from your vision is usually very noisy, is not reliable, all the time jumping, it doesn't tell you where exactly things are. Of course, for a human, you have this data coming and saying, okay, this is the cup and it's located there. Every now and then it jumps away, but for human, it doesn't really matter. But for a robot to make a decision, that's this difficult challenge. So what we have been trying to have solved is that how you deal with uncertain vision data, how you deal with the low frame rate, because to do actual control, you need very high frame rate. So how you deal with the low frame rate, and how you actually make a decision in when the data is uncertain. So all these things, you put them all together. And you get, well, see here, this is the work from, are you doctor already? Okay, yes. So He's quite fresh, PhD defense a month ago. So how you deal with the low frame rate, data uncertainty, and complex decision making about how you deal with the sensor characteristic. Let's say vision in the long distances is not very good, and it gets closer, it gets better. How you actually make decision based on this data. Last few pages of my talk will be basically that was about the research, and now I'm talking about what we have in the lab. A couple of them you saw already moving. So you saw the Avant Techno mini loader, at least one of them up there. And then the Ville multipurpose loader, the yellow one that I showed there. As well, although they are Avant Techno mini loader is called here, but on the shell is the Avant Techno. Under the roof is nothing to do with the Avant Techno, because everything has changed. Students have changing all the pumps and motors except the diesel. Everything is changed. We have excavators. We have a test area of 4,000 square meter, 250 meter test track, asphalt, gravel for earth moving activities like that. We have also a very good thing that has been very useful. I remember when I used to work in the lab, before we didn't have this, we used to freeze our hands in the winter. Now we have a warm in winter and cold or cool in summer cabin there. We can actually sit behind the glass and see what the machines are doing. And I'm hoping in the future when the operators can do the same thing, so they don't have to sit like in the Ponson machine or a construction machine with all those vibrations and the cognitive load that they have on the machine. They could do it either on-site remotely or off-site teleoperation. Back in 2012, when we have this, we built this M12, what we call the mobile 12. 2012. We were quite many people always working there to be able to run one machine. 2018, Eric did all his research alone. So we are quite mature in operating these machines. And this is the lab. Thanks to Pauli and the university funding, we have had a lot of new gadgets in the lab, from collaborative robots, mobile robots, to all sorts of different state-of-the-art sensors, Velodyne, time-of-flight camera, LiDARs, normal cameras, inertial sensors, ultra-wideband sensors. So students in the lab, they build and kind of put up all these things together. They build new systems. They basically build new robots and new knowledge. So at the moment, this manipulator is not working, but I'm hoping in a year or two, when we have the final seminar, we will serve you coffee or cake with this robot. I promise it, okay? This will be my last presentation, or a slide.
Any questions for Reza?
Okay, you may catch up also during the coffee break.
Yeah, maybe everyone's eagerly waiting for the...
Yes, there is a question up there.
Oh.
So at the moment, robots like this seem to be kind of getting this to work seems to be quite difficult. You need a lot of experts to get your robot to move and do the action you want. Do you have any estimate on when things start to get easier, such as some supervised learning problems today? Some simple prediction problems are easy today, but what do you think when the tools will develop so that we can way less expertise to get something done?
human environment is quite complex. Means that I showed in one of my slides that the robot needs actually to interact, and that interaction is still robot. As a kind of robotic engineer, I like to solve complex problems, and then when I talk to some of people that do human-robot interaction, they don't want to solve a complex problem in terms of hardware, but they want to solve complex problem in terms of interaction. I don't understand their language, and they don't understand my language, and then that's the one thing has been there. So at least during the AI Hub, we are trying to bridge that gap, so to understand better what are the needs from their side. But as I said, the environment of the human is complex. Bringing these robots out is rather, we need to solve new problems. For example, one of the problems, as I said, that when you want to run the robot in the human environment, robot needs to understand human. Okay, that's what has been robotics has been solving that. Less research has been on actually when the robot moves in the environment or does something, how human perceives that. Been less studied in that sense. So if you want to feel safe around the robot, you need to understand, to predict robots. Now, answering to your question, many people have been promising to bring the autonomous cars in the streets. I don't believe that will happen in 10 years. The same with robots. There are certain things you can solve with slow motion robots, collaborative robots, because they are rather safe. Certain things can be solved, but not really huge. Well, it will be case by case. My answer. It will be case by case.
I can support. It took me 1.5 years and several peers until I started to understand what Reza is talking about. Now that we kind of like take this time to start to understand problems in the both kind of like disciplines, I think that now the progress is really, I can see that it is doing very well, and this is more and more what we need to do. Stop being in our own silos and kind of like comfortability zones, and actually jump to the zones that are very uncomfortable, because that is actually the zone where every development happens.
You should check the type of beer you drink. Yeah.
There's of course, one thing also is that there is a lot of hype in robotics and AI, and then as Heikki said, we need to understand the limits, and then the hype is because there is a lot of hope. I don't want to disappoint you, but there is too much hope in that than reality. Therefore, it can do a lot of things. I don't disagree, but it's because many people get involved in robotics and AI that are not from the field. They don't understand the technical difficulties, and they have visions, but reality is a bit different.
Rodney Bruce recently said that the near future we always overestimate, but the far future we always underestimate. So I mean, this is very important to keep in mind. Sorry, I'm talking all the time.
Sure, okay, it's good. Yes. Any more questions? Okay. We talk more on the coffee time.
Yes, thank you, Reza, and I would like to take the opportunity to thank all the other speakers as well. Thank you for this interesting seminar, and we are just in the beginning, so we will start the operation of the AI Hub as soon as we can. We are organizing events already this month, and we are organizing workshops already next month, but we are still in a process of ramping up, so we are hiring people, we are finding the experts that we need in our practical operation. But stay tuned, follow tampere.ai and our Twitter account as well. And now it's time for the networking part. There will be coffee, there will be joulutorttu outside, so go outside from the upper door, and right outside of the door there will be the cafe. Thank you.